For topic two, we're going to look at solving right triangles, but in this situation, we're going to need to use inverse trig functions, okay? No big deal. I'm sorry, I have to adjust sometimes. No big deal, but we do have to remind ourselves of a few things when we start using these inverse trig functions, okay? But I have complete faith in all of you. Now, the standard lettering for a right triangle is as follows. We kind of already talked about this in the previous video. You generally are going to see these triangles in this section, the right triangles and the oblique triangles that we're going to look at in the next few sections. You label the angles capital A, capital B, capital C, generally kind of like in order. And then the side opposite the angle is going to have a matching lowercase letter, okay? Now, with us, we always label our hypotenuse C when we're dealing with a right triangle, and that angle, the largest angle, the 90-degree angle, is going to be angle C, okay? But there you have it. That is the standard lettering for these right triangles, okay? Now, we do need to remind ourselves of just a couple of things, okay? When we're dealing with these inverse trig functions, we have to be a little bit careful with them, okay? Remember a couple of things. So, standard trig functions, okay? Standard trig functions, the input is an angle. We'll say the standard trig functions operate on an angle. That means the input is an angle and the output is going to be some kind of a trig ratio. Okay. Now with the inverse trig functions, the input is the ratio and the output is going to be the angle. Okay. And there will be situations, especially in the next section, where we have to be a little bit careful with what the input is. Okay, so we have to remember domain and range. Okay, so just really, really fast, we're going to go through this quick. If we're dealing with inverse sine, okay, the domain is -1 to 1. And the range, we could only consider angles that were from -pi/2 to pi/2. Okay. Now, this stuff isn't going to be as big a deal, but there is a situation that I can think of for sure in the next section where we need to be very mindful of the domain. Okay. Cosine, if we had inverse cosine, the domain, again, -1 to +1. And then the range was 0 to pi. So really just pay close attention to the domain. That's going to be the bigger issue. And then for tangent, the domain was everything. It was all real numbers. And then the range was very similar to sine, except we couldn't include the endpoints. It was -pi/2 to pi/2. So again, don't get too bent out of shape about this. Number one, you should already know it. But two, we may have situations where we have to kind of look closely at the domain, especially in the next section. Okay. For now, let's just sort of get to it. So example 3 says draw each right triangle and then solve. Round all decimals to the nearest hundredth, so 2 decimal places. So it says solve the right triangle where side B is 12 meters and side A is 6 meters. So we know we have a right triangle. Pretend that's not quite so wonky. All right. So we know this is 90 degrees right here. So we know that directly opposite the right angle is side C, which we don't have. What we do have are sides A and B, and it does not matter which one you label which. So let's say we have A is 6 and B is 12. So that would make this A and this B, okay? Because we want the side opposite the angle to have matching letters, just one capital, one lowercase, okay? And if it makes you happier, you could flip them, which I guess if I was going to be consistent with what I've been doing, it might make more sense to flip it and say this is B, this is A, which would make this A equals 6, and then this would have to be B equals 12. Okay? Either way is fine. Just be consistent with your angles and your side lengths. They have to have angles. The opposite side has to have a matching letter, just lowercase. Okay? So what can we do here? Well, we want to solve the triangle, which means we want to find the length of all the sides and the measure of all the angles. So let's start with the easiest part. We have two sides of a right triangle. We can use the Pythagorean theorem to find the third. Okay? So to find the side length C right here, we're going to do the Pythagorean theorem. So I know the Pythagorean theorem says if I take the first leg and square it, add it to the second leg squared, I get the third side, which is the hypotenuse, squared. Okay? Well, 6 squared is 36. 12 squared is 144. All right. And 36 plus 144 is what, 180 maybe? So we get 180 equals c squared. We're definitely going to want to use our calculator for this. So let's go over to the calculator really quick. Oh, shoot, I'm on the wrong screen. There we go. So we want to take the square root of 180 and we get plus or minus technically 13.42 if we round. And we're rounding everything 2 decimal places. So we would get 13.42 is the length of the hypotenuse. And that should make sense because we know the hypotenuse is the longest side. And so far, C right now with the work we've done, it should be the longest side, and it is. So we get 13.42, and that is side C. Okay, now for the angles. We know what C is. We don't have to do any work there, but we've got to find A and we've got to find B. So what should we do? It's kind of up to you. We only have to do work for really one of them, and then we can use the fact that interior angles of a triangle, they all have to add up to 180. So let's say that we look for B. Let's say we just kind of want to try for angle B here. So what is angle B? Well, we want to use as much exact information as we can. So I kind of want to stray away from anything that requires the hypotenuse because the hypotenuse has been rounded. So if I use a rounded value in another formula and then I have to round again, I just get like this compounding of like round off error. So let's use the fact that we have the opposite side to be and the adjacent side to be. So that's tangents. Remember, tangent is opposite over adjacent, okay? So if we wanted to find tangent of angle B, we don't know what angle B is yet, but we've got the skills, I promise. It's going to have to equal the opposite side over the adjacent side. So 12 over 6. If we wanted to simplify, we could, and we could say tangent of B has to equal 2. Okay? Well, we're stuck. Or are we? Okay, we shouldn't be completely stuck because we have this one trick up our sleeve. We can take tan inverse of both sides. And I'll probably show you the work here and then we'll just kind of do this in the future. But if you take tan inverse or inverse tangent of the two sides, this right here, if you take the inverse tangent of the tangent, they just sort of like unwind each other and you're just left with the argument. So you're left with basically just B. Okay, so tan inverse will undo tangent and you get just B. And then in our calculator, what we're going to do is we're going to type in tan inverse of 2. And you still want to be in degrees because we're talking degrees here. Okay, so let's go over to the calculator. We want to do tan inverse of 2. And in case you forgot to get to the tan inverse, notice we've got sine, cosine, tangent, and then in the corner in blue, we have inverse sine, inverse cosine, inverse tangent. So to get to inverse tangent, we go second tangent, and then just type in whatever the argument is, which in this case is 2. And we're going to round 2 decimal places, so we get 63.43 when we round. So 63.43. So B is 63.43 degrees. All right, so 63.43. It may not fit very nicely, but we got it in there barely. Oh, shoot. I didn't mean to undo my whole triangle. There we go. Okay, so the last thing that we have to find is the measure of angle A. And if we have two angles, we can easily find the third. So we don't really have to do a trig function here. If I want to find angle A, I've got 180 degrees. We already used 90 for angle C, and then we're going to subtract 63.43. That's what we used for B. Whatever's left over is what we're going to have for A. This is pretty easy, so we won't worry about switching to the calculator screen. Just get your calculator out. So 180 minus 90 minus 63.43. And that tells me that angle A is 26.57 degrees. And we have now solved this triangle. So you know you're done when you've got the length of all three sides and the measure of all three angles. And so we were able to do it. We used an inverse trig function, all right? So kind of bring that information from chapter 8 back to the surface, okay? Now for part B, it says solve the right triangle where side C is 11 inches and side B is 4.4 inches. So let's draw our right triangle. So we know we always label the right angle C because we label the hypotenuse of right triangles little c. All right, whoops. There we go. So we'll say this is A at the top, and then off to the side we'll say is angle B. So opposite A is the side length little a, opposite B is the side length little b, and let's fill in what we know. We know side C is 11, and we know side B is 4.4. And it is technically inches. Okay, so let's do the Pythagorean theorem first to find A, and then we can do some inverse trig stuff to find one of the other angles, A or B, and then we can just use the interior angle stuff, okay, to find the missing angle. All right, so the Pythagorean theorem, if we want to find side length A, well, I know that A squared plus B squared is equal to C squared, okay? So let's see here. A squared, we don't know. 4 squared, or 4.4 squared, I'm just going to do that on my little calculator on my table. That is 19.36. 11 squared is 121, okay? To get A squared alone, I need to subtract 19.36 from both sides. And that's not right. We hit the wrong button, y'all. So we get 19.36. So 121 minus 19.36 is 101.64. And then we, of course, want to take the square root of that. So the square root of 101.64 is, I get 10.08. Okay, so A equals 10.08 if we round. Okay, and I trust that you all can do that on your calculator. Okay. So we've got 10.08 for side length A. Great. Now we've got to do the inverse trig stuff. So we just kind of have to pick an angle. Do we want to look for A or do we want to look for B? Doesn't really matter, okay? So let's say that we're going to look for B again. Okay, so I'm really interested in finding angle B. Well, I want to avoid side length A if I can. So that's the adjacent side. And remember, if we have SOHCAHTOA, all right, we would end up doing the adjacent side if we did cosine or tangent. So I'm really liking sine in this case because it has the opposite side, which is exact, and the hypotenuse, which is exact. So I'm going to do sine of angle B, which is unknown at this point, but we've got the inverse trig functions. So we're going to do sine of angle B. It has to equal the opposite side, which is 4.4 inches, divided by the hypotenuse, which is 11 inches. Okay, I can do a little bit of work here. It's not going to be that big a deal. I need to get the B alone. Okay, so remember, we can do that like sine inverse of both sides. And when we do the sine inverse of both sides, sine inverse just kind of wipes out sine, leaving me with just B. So I get B equals inverse sine or sine inverse. I'm not going to get my drawers in a knot about what you call it. And it's going to be inverse sine of 4.4 divided by 11. So let's see what we get here. So we're going to go to the calculator and we're going to do inverse sine. So second sine. And we want, what did we have? So it was 4.4 divided by 11, I think. Quote me, don't quote me on that. All right, and we get 23.58 if we round. So 23.58. Yeah, 23.58 degrees. So that is angle B. Okay, now do we have enough information to find angle A? Of course we do. So A, we know that we've already used 90 degrees for angle C. So we've got 180 minus 90. Whatever is left, we've got to split between A and B. So I can go ahead and subtract the value for B, which is 23.58. So angle A is going to equal, just give me a quick second here, 90 minus 23.58, and I get 66.42 degrees. So 66.42 and 23.58. I drew my triangle a little bit too small, but there you have it. That is solving a right triangle where you do have to use those inverse trig functions. So if you're looking for an angle and you don't have enough information, like you don't have a third angle, you've only got like one angle, but you've got the sides of the triangle, you can use an inverse trig function to find that missing angle. Okay, so there you have it. That's solving right triangles with inverse trig functions.